Okay, chapter 13 is going to follow chapter 11. Chapter 11, what we learn is parabola. And for this function, we find the vertex and the formula for vertex. We have the formula for x-coordinate h, and then plug in h to the formula. Then we can find maximum or minimum value k. Now, chapter 13 is very similar. One part, when we are talking about parabola, is very similar. We rotate the graph 90 degrees. So when we rotate the graph, basically 90 degrees, x rotate 90 degrees goes to y-axis, and the y rotate 90 degrees become x-axis. So basically, when we have a vertical parabola become horizontal parabola, basically we exchange x and y to have the new function. We don't call it a function because the horizontal parabola is not a function. It won't pass the test of the vertical line test. But anyway, a function or not a function, they are all exist, and we can try to graph them. And the formula are similar, just the k and the h. The formula is changed. Okay. Now, but the real chapter 13 is not only parabola. We are talking about conics. What conics means? It looks like a cone, and you have a upside down cone all together. And if you use a piece of paper, go across the graph or slanted, or this direction, then this paper will cut the cone to have a shape, either circle, ellipse, parabola, or hyperbola. So that's first the concept. Why we talk about conics? Because those shape was created from this type of the shape here. Circle, ellipse, parabola, and hyperbola. So this is hyperbola. This is parabola. And here we don't study this type of the parabola. We only study vertical, up, down, or horizontal, left, right. Okay. And the ellipse, here we don't study the slanted ellipse. We have vertical ellipse or the horizontal ellipse for chapter 13. And the circle is a special type of ellipse, means all are round. Not like an ellipse. One side is longer and the other side is shorter. Okay. So this is chapter 13 all over. We want to talk about. Now, keep going. We focus on circle. Now, all the detailed calculation will be on our classwork PDF file. And right now here, we only roughly talk about the concept, not the detail goes to the calculation. So how is the circle formula came from? Basically, if you have a center and the definition of the circle means the radius goes to anywhere, or the center goes to anywhere on the circle. Every point on the circle connect with the center HK. This distance we call it radius, and the radius is the same everywhere in the same circle. So let me erase those marks. Okay. Okay. Now, since the radius are all the same, then we can calculate the radius. Okay. So if this is x, if you have point xy on the coordinate, this is x, this is h. The distance between x and the h and the center, we better use absolute value. Okay, and the distance between y and the k, we better use absolute value because we are not sure always y and the k which one is bigger. Okay, and since r is the distance between, and also you can take a look here. This is the right triangle, so we may use Pythagorean theorem. A squared, so leg 1 squared, x minus h squared, plus leg 2 squared, y minus k squared, equals to distance, these two distance. Okay, so basically I'm using distance formula. Distance formula. The distance formula basically if you have a distance. Okay. How you calculate the distance? The distance is the x minus x, x minus x, which is h here. So you have x minus x, and then y minus y, y is k here, y minus y, and then square by Pythagorean theorem. This length square plus this length square is the r square. So if we square both sides, and basically square already take care of the absolute value. So we may just use this x minus h squared plus y minus k squared is r squared. So the circle formula is pretty straightforward by Pythagorean theorem. Pythagorean theorem. Now next we have a ellipse. Now ellipse is some kind of not balanced circle. So formula is similar to the circle. Okay, x minus h, y minus k, but we want to adjust because the radius is not always the same. Therefore, there will be some adjustment under the denominator. But the real definition, true definition for ellipse is we need to use focus. If you have two focus, then we say foci. It's a pearl. Okay. Now, On the formula, we don't see any formula. We don't see the formula talking about anything about the C. That's because after you use distance formula, you want to calculate this distance and this distance. And these two distance plus together need to be a fixed number 2a. A is this one. Okay, this plus this. So in other words, let me erase all the marks here and then let me show you what's the real definition for the ellipse, which is any point on the ellipse. If you connect this point with left-hand side focus and the right-hand side focus, it will create two distance. And these two distance plus together is a constant number. But what's the number? So it's very interesting. I want to show you. It's very easy to find out what's this constant number. Why it say it's 2 times a. So let's take a look. This is the point on the on the ellipse. So the distance d1 basically is, you subtract these two numbers, right? So will be c minus a. So it need to be negative c minus negative a. Negative c minus negative a become a minus c. Okay, so this is d1. And how about d2? For the same point xy, here the distance, let me change color to some special color. So from here to the other focus, what's the distance? This one plus this one. Okay, from C to negative A. So D2 is C minus negative A. When you want to find the distance between two coordinates, just subtract them. The big number take away the smaller number. So it becomes C plus A. Therefore, D1 plus D2 is A minus C plus C plus A. And you cancel out the C. So it's equals to 2A. Because this point is one of the points on the ellipse. And we so-called ellipse means, no matter which point, if you connect four sides, these two focus, D1 plus D2 always the same, so will be same as 2A. Now this proof is not so important for you, just for you to understand. Our formula is not came from nowhere. It's for some reason we have this formula. Okay. Now you may see two different types of the ellipse. Sometimes it's horizontal. Sometimes the ellipse is vertical. And yes, we don't talk about the slanted ellipse yet. In our chapter 13, we only talk about two types of the ellipse. And these two types of ellipse, the formula are very similar. Always x minus h, y minus k squared. Always like this. But because it's not a circle, therefore the denominator will be different. If you have same denominator, then it will become radius. So if you have this square plus, if we have, we say a square, if these two numbers the same, then we just multiply a square on all the terms, and then cancel out. So you are going to have x minus h squared plus y minus k squared equals to a squared, or you say r squared. So when you have a equals to b, then you have circle. It's not an ellipse at all. So ellipse a not equals to b, right? Okay. So this is for the detailed calculations, how to do the transformation. Here, this is hk, center is hk. Okay. So when you have hk equals to 0, 0, then the center will be origin. And this is a0, negative a0. But if your center is not 0, 0, your center is hk, then all the coordinate will be different. Let me see if I have some space. Okay. So if center is 0, 0, if center 0, 0, if center 0, 0, then four vertex will be a0, negative a0, these two, a0, negative a0, and 0b. Here, 0, negative b. If center is hk, then this four vertex plus hk, plus hk, okay, plus hk, plus hk, plus together, okay. So it's a plus h, okay. This will be negative a plus h, okay. This one will be h b plus k, and this will be h negative b plus k. So we have this type of work on our homework. You can see, you can try. Now next we go to hyperbola. Hyperbola have similar formula, okay. And this similar formula just change subtraction, addition to become subtraction. The ellipse formula, you have addition. And why we have this formula? Because if you follow the distance formula, well, very complicated calculation, and equals to 2a. Okay, so you calculate the distance 1, distance 1 plus distance 2. That's very complicated calculation. You may find the detailed calculation if you prefer to read. Is understandable. You may find it on our PowerPoint. You can find all the detail there. But right now, I just want to simply tell you, after the detailed calculation, we have this very simple formula, and this two simple formula, you don't see C at all. C means the focus. You don't see C involved in the formula. It will be cancelled out. Okay. And the same thing for the hyperbola. It's very similar proof, but this time is not d1 plus d2. For ellipse, is d1 plus d2 equals to 2a. That's ellipse. For the hyperbola, it's subtraction and absolute value because sometimes D1 greater than D2, sometimes D2 greater than D1. So similar idea, D1 minus D2 will be equal to 2A all the time, no matter where is the point. Okay, and I'm going to skip the detail, very complicated proof with the square root. And we just simply understand how the formula came from. And the hyperbola, we have subtraction between. Now hyperbola is a little bit complicated to use the formula. If you have horizontal, when you have x squared subtract y squared, then you have two branches on the x-axis. If you have y squared in front to subtract x squared, then you have two branches happen on the y-axis. Okay. Now, there's one more thing more complicated for the hyperbola is how you graph the hyperbola. Some students graph this. Wow, that's not right. Okay, because the hyperbola is supposed to follow the asymptotes. Asymptotes means there is the line the graph will follow. So this is the asymptote. Let me extend. Therefore, the graph is supposed to follow the asymptote. Okay? So your graph is supposed to follow asymptote. What it means, even though the graph is not going to follow the asymptote all the time, but in the end, in the long run, means when s become very big, or when s become very small. In this case, in the end, the graph will behave like a straight line and follow the asymptote. Okay? Okay. Now, how we find the asymptote? Very easy. Do you see A and B? Okay. So you have A, you have A and B. So if you remember, slope is rise over run. So rise up B and the run is A. And you have two directions. The other direction B and a negative A, or B negative A. So basically the slope will be positive B over A. So this B and A will tell you the slope of the asymptote. Therefore, how you graph the hyperbola? Let me start all over. Let me erase those marks and show you how to graph. Clean first. Oh, it's better, right? Not too messy here. Okay. Now, how you graph? First, you find A and the B. A and the B here, so make a rectangle. You started the line. Okay, you can see on the screen is already started the line, but I make it solid to make sure you can see better. And then connect the diagonal. Connect the diagonal and extend the diagonal. This will be our asymptote. Same thing, connect these two diagonal, and this is the second asymptote. Okay. So this is the and then our graph always start from not from C. Okay, our graph start from A, and then curve up, follow the asymptote. Curve down, follow the asymptote. Same thing, start from negative A, curve up, follow the asymptote. Curve down, follow the asymptote. Then it's done. Then how about if our center is not 0, 0? How about if our center is HK? If our center is HK, then this A0 plus HK. Okay, and here negative A0 also plus HK. And the asymptote y equals to b over ax, right? This is the slope. And you understand that if you shift the whole graph to HK, then x need to remember chapter 11 with the minus h, y minus k. Make sense? Okay. So same thing. The other. Oh, let me change color. The other asymptote b negative b over a x need to minus. Okay. And the x minus h, y minus k. Then you can easily find the new asymptote. I think our homework for ellipse may ask you to have new center HK, but most of the question from hyperbola probably the center will be 0, 0 because probably it's too hard for the students. But if you understand all the concept, I consider it's actually not that hard. So the last example here, if center is 0, 0, then you have this formula. If x squared in front, then you have horizontal hyperbola. If y squared in front, then you have vertical hyperbola. And the last one is just the example. Here we can quickly go through. The number x take away. So plus means take away negative 2. So your center is negative 2 and negative 1. So it's not vertex, it's a center. Okay. On the parabola, the number x, y take away is the vertex, but on conics, not the conics, on hyperbola and the circle and the ellipse, we have HK is the center. HK is the center, not the vertex. And what's the vertex here? This is the vertex. We also call B is the minor vertex. So this distance is A. This distance is A. This distance is B. Okay, so pretend it's 0, 0 on the center. Then this is A0. So this one supposed to be A0, right? A0. What's A0? A is 7, 0. And the B is supposed to be negative 7, 0. another b, the other side, -8, -7, 0. And the b is 5, so here you have 0, 5, 0, -5. But however, our center is not a 0, 0. Our center is -2, -1. Therefore, I need to plus -2, -1 here. Plus -2, -1 here. I plus -2, -1 here. I plus -2, -1 here. And also I plus -2, -1 here from 0, 0. Okay? So you have 5, -1. This one. And the plus together you have -9, -1, -9 here. Okay? And this one you have 2, 4. 2, 4 didn't stay. So this is 2, 4. And this -2, -6. Together. Right? And how about the asymptote? Asymptote, you pretend your center is 0, 0, and the y supposed to equal to b over a x positive negative. But since we have new center -2, -1, so I need to shift to -2, -1. So this will be our new asymptote. And you may solve for y to simplify. That's more detailed work you can do. Okay, so I'm done with chapter 13. And this type of the center, how to transform from 0, 0 to HK, same thing. This is very important. Okay, you can see that if you go to trigonometry, you still need to learn this type of skill. Okay, so see you next time. Bye bye.